Our interest is to have a feel of how questions can be asked. So this is one of the questions that can be asked. Solve the inequalities, that type. Then you accept a job with an annual income of that. This includes your salary and the 1,000 year end bonus. You are paid twice a month. What is your salary per day? Per day period. Use Pascal's triangle. Solve the equation that equal to that. Find where possible the term involving x power 4 in this expansion. Evaluate the limits, and the limits are given here. Here's a graph of the following function, determining if it's continuous at the given point. So you see, this was another question given to the same people. So it was that thing where this guy here is given this paper, the next one has another paper. So the questions are different but similar. So also much different from what you know. But I think we are here for the test. So I want to revise this test paper. Of course, this was 1100 testing. Okay. So question 1 says, find the domain of f expressing your answer in interval notation. So question 1A, part 1, we are given the function f to be equal to the root of minus 2x squared plus 6 plus x plus 6. So we are told to find the domain expressing the answer in interval form, and we are given 5 marks if you manage to get the correct one. Now, the domain of every root, we want the inside of the root to be greater or equal to 0. Always, whatever is inside the root must be greater or equal to 0, because don't allow a negative in the root. So now this whole thing inside should be greater or equal to 0. So then, well, this is a quadratic. We start by equating it to 0. So we say, okay, this quadratic, can we find the product? -2 times 6, that's -4. What about the sum? The sum is +1. So can we find the factors? I think we have 4 and -3. So we can write this as -2x squared plus 4x minus 3x plus 6 is equal to 0. So we factor out the -2x, so that we remain with x minus 2, the -3, and x minus 2 is 0. So we have x minus 2 and -2x minus 3 is equal to 0. So we get x minus 2 is 0, or -2x minus 3 is 0. The target here is we are getting the critical numbers, -3/2. And then we quickly rush to the number line and place our number, -3/2 and +2. In between them, there's a 0. Remember, we always want to use 0 because it's very easy for calculations. So we place 0 even here in the product. So if we have a 0 there and a 0 here, we remain with -2 times -3, which is equal to +6. we're interested in the sign, positive. And then meaning that this side will be minus, that side will be minus. So whenever we get such, then we have found the domain because our domain should be an interval where we have a plus. So from -3/2 to +2. And we include both of them. Like that.
So I have a question.
Yes.
So doesn't mean you have to test them every single time you find the final answer.
Then you have to, because it's a product and against the inequality. So we always need to test.
Okay. Thank you.
Thank you. Okay, so we go to a different question. We go to part 2. Sketch the graph of this polynomial, clearly indicating the x and y intercept. So now we need to do that polynomial. So we do the polynomial part. The polynomial is in part 2. F of x is equal to x power 3 minus 2x squared minus x plus 2. So if you want to sketch a polynomial, you first need to find the y-intercept, since they have said indicating all the intercepts. So the y-intercept, you substitute 0 where there is x. So we get 2. That is 0,2. The x-intercept, we equate the function f to 0. So we have x power 3 minus 2x squared minus x plus 2 is equal to 0. So when you equate it to 0, you now need to find the factors so you can factorize it. So if we try 1, in f of 1 will be 1 minus 2 minus 1 plus 2, which is 0. So 1 is a part. So I can use synthetic, pick the coefficient of this guy, 1 minus 2 minus 1 equals to 2. And drop the first one down, multiply, do the addition, multiply, the addition, we finally get 0 down to as the remainder. So we can now write this guy as x minus 1, the one we have used to divide, and this polynomial here, which is x squared minus x minus 2 equated to 0. So we have x minus 1 is 0, or x squared minus x minus 2 is 0. So here, x is 1, and the quadratic, you find the factors again, that's -2 and +1. So we have plus x minus 2x minus 2 is 0. So we get x plus 1 minus 2 x plus 1. So we have x minus 3 and x plus 1. So that is x is equal to 2, x is equal to -1. So now I have all the intercepts. Also, we have the y and the x-intercept. So the x-intercept, we have -1, we have +1, we have +2. The y-intercept is 0,2. So now, because the space between -1 to 0 and 0 to 1 are equal, so we'll make that to our turning point. Because normally you want to approximate that. So look, this does not mean that the intercept, the y-intercept is the turning point. You always look for the bigger space. That's where you put your turning point. If I had something like this, -3, 1, approximately 2, I was going to have a turning point in this interval. Because the gap from -3 to 0 is bigger than from 0 to 1. So I would always look for a bigger gap, but if they are equal, then I may want to assume that the y-intercept is actually 10. Okay. So quickly, we go back and check what the next question was saying. So it's saying, hence or otherwise, from part 2, determine the solution set of the inequality f of x is greater than 0. Another 3-5 marks there. So hence or otherwise, the hence part is saying, if you want, you can use your sketch to find the solution. The otherwise part is saying, well, you can use a factorization to find the solution. But the target is, we want to find where f of x is bigger than 0. So f of x becomes greater than 0 where the curve is above the x-axis. So you want this region where the curve is above the x-axis. Also, this region where the curve is above the x-axis. So we're saying the solution set here is equal to -1 to 1 union 2 to 3.
That's what's that? 5 marks.
Yeah, you have the formula. It's so simple. So that's question 1A. That paper we're doing. So next, so on the last part, whenever you have a question that is asking to find where f is greater than 0, they're asking to find where the curve is positive. Now, the question of whether the curve is positive or not is about the y value. The y value is up here, they're positive, and down here, they're minus. So you got your curve and check which part of the curve is above the x-axis. That is where it is positive. Now you're not getting the numbers where it is positive. You are getting the x values for which the curve is above 0, is above the x-axis. So but you can decide to mute if you don't mind. Good. So you want to say for these values of x, the curve is positive. Because greater means positive. Whatever is bigger than 0 is positive. So that's why you pick this space here, because it's above the x-axis. Now for what values of x from -1, this space here, because it's above the x-axis, What values of x? From 2 to positive infinity, because the curve continues. Keep going. That's the one here. Okay.
Sir,
Hello.
hello, sir.
Uh-huh.
Yes, I have a question. The negative 1, 1, how are you getting it? Like this, the curve here where it's saying it's positive, here where it's up. Like I don't see the one here, negative 1, 1. How the 2, infinity I'm understanding, but the one negative.
So this is -1 from here up to here. Positive 1. So I'm saying the curve for the values of x between -1 and 1, the curve is above the x-axis. It goes like that. So it is positive. What is positive is the curve. For what values of x? Between -1 and positive 1. So we don't get these values. We get the x that is giving us those values. Don't know if that is clear.
Thank you.
Let's go back to the question paper. B. Solve the following inequalities, expressing your answers in interval notation. X plus 6 over x plus 4, less or equal to 2. X plus 6 over x plus 4, less or equal to 2. So how do we solve it? So on part B, part 1 of it, x plus 6 over x plus 4 is less or equal to 2. In inequalities, we do not cross multiply. So you move and do that. And then we get x plus 4. So we'll have x plus 6 minus 2. When you divide by 1, you get x plus 4. Then you expand. And then you have this. So you work out, you get minus x minus 2 over x plus 4 less or equal to 0. So from there, you equate the numerator to 0 and get x is equal to minus 2. The denominator to 0 and get x is equal to minus 4. Then you got the number, right? Having minus 4, having minus. We will find 0 in this region. So we can substitute 0 while in x to get 0 minus 2 over 0 plus 4, which is minus 2 over 4. The interest of the sign. Meaning here is plus, here it's minus. The question says, can you get where it is less or equal to 0? So the solution set is going to be from minus infinity to minus 4. We don't include there, we don't include minus 4 because it's coming from the denominator. Union minus 2 was to the infinity. We go back and include minus 2 because it's coming from the numerator.
Excuse me, sir.
Hello.
Yes, sir. The reason why -4 is not included, is it because when it is included, it will make the whole function undefined?
Yes.
Thank you.
Mm.
Excuse me, sir.
Hello.
Could you please repeat on the 0 minus 2 over 0 plus 4?
Today we're just testing, like you pick a number that is in any of those intervals and see what value you get.
Okay.
So pick 0 and substitute it and see what value you get. Then question 2, to remove the absolute, you say plus or minus 2x minus 3 is greater or equal to 5. You see? That means plus 2x minus 3 is greater or equal to 5.
Ate?
Or
Soon, probably.
or minus 2x minus 3 is greater or equal to 5. So you have 2x is greater or equal to 5 plus 3. That is 2x greater or equal to 8. Divide by 2, divide by 2. So get x is greater or equal to 4. Or this side minus 2x plus 3 is greater or equal to 5. That is minus 2x is greater or equal to 5 minus 3. And so minus 2x is greater or equal to 2. Divide by minus 3. So you have x less or equal to -1. So now the solution set is going to be the union of these two. So I get them -1 greater or equal to x, which is greater or equal to 4. Another solution.
Sir,
Well,
I have a question on the solution set. Is it okay if you, okay, I've seen a method where you just test the numbers into the equation and then you pick one of them as being the solution. You don't do it here.
I think you didn't see it, okay. You don't do it again. Because then you have so many numbers. So you find some people would want to write this as -1 union or positive. It's simple. You know, we can. Yeah, you come up. Yeah, you can. But when you come up with that solution, it's between this one that one. So your exercise here is you solve 1 x plus 6 over x plus 4 greater equal to 2 and 3x minus 3 less than equal to 5. So just try and see if you also solve.
We are solving it now, sir.
That's the thing. I hope you have time to think because it's looming going to cut within 5 minutes from now. I don't think we'll do much. So what we do is we pause for 10 minutes to allow the video to record. And then we join. This is 1847. So 1857. We join again.